have a look into some of the TrueFoundry MCP Gateway features, where we'll walk through the platform and show you how it's implemented. By the end of this session, you will develop a foundational understanding of MCP. You will understand certain frontier challenges in operationalizing MCP and also a hands-on walkthrough of the platform. So firstly, let's start with understanding MCP from scratch. So what used to be the landscape of agentic AI pre-MCP, right? So LLM agents can reason, code, and generate with a lot of fluency. But the bottleneck is they need a lot of context engineering to discover the data in the organization, be it customer data, inventory data, workflow data. So LLM agents are powerful, but this context engineering is somewhat disconnected from the systems in the sense that there is no dynamic discovery that occurs for your data that is residing in different places in the organization. So how do we enable that? And let's have a little bit more look into context management. So what do we, what are the different solutions or different aspects which need context management? One is prompting, right? So remember, agents are typically comprised of three main things. You have a prompt, you have the LLM, and you have certain tools, right? So prompt management is one of the cornerstones of context management. And typically how it's done is the LLM either knows something or it doesn't know something, right? As per the prompt. So you have to, earlier you had to do a lot of manual prompt management, which is still there to some extent, but either the LLM knows something or it doesn't know something as per what is there in the prompt and its training knowledge. Second thing is RAG, which also was very popular back in 23, 24, and it's still now. But again, the model is not initiating lookups. The developer instead is putting all the logic in the application code, and that's how RAG is getting implemented. And finally, function calling, which is just tool calling and agents. Here, developers integrate new tools, and this typically means custom prompt logic and parsing, where for the tools, you have to mention what is the tool name, what does that perform, and what is the schema of the tool, right? So you have to pass in a lot of information so that the agents can actually work, they can actually call the tools. And tool calling is typically one of the bottlenecks in terms of performance of agents, right? So if agents are failing, it's likely that they're not able to call the right tool in the right order, right, at the right time, and so on. Or there is a bottleneck in the context. So this is the primary backdrop, which is context management, right? And you have to do a lot of extensive engineering pre-MCP to get this right. Let's have a closer look into tools because again, tools is one of the main things when we are working with agents. So manual wiring had to be done between every agent and tool. Think about, you have M agents and you have N tools, right? Tools can be regarding emails, calendars, connecting to databases, or even local file systems, right? And tools can perform different things, right? So you had to engineer this manual wiring between each agent and each tool. And one of the issues here again was that the tools, right, had to deal with fragile and inconsistent APIs. So the APIs that these tools were, built for, the API definitions could change over time, right? So you had to again go back and figure things back into your application code. You had to correct things in your application code. And again, there's a lot of repetition which is occurring because you do this for one agent. You connect, let's say, 4 tools for one agent, and you have to, let's say, build another agent for some other team or some other application, and you have to again, do that again manually. So it's not that you cannot do it, it's just that there's a lot of manual work and there is a lot of inconsistency and fragility involved when you're doing this kind of a manual wiring. Now, this is where MCP actually comes in. So the basic idea behind MCP is that it standardizes how applications provide context to LLMs. So the backdrop in one line is just that it's standardizing how applications or agents are, sorry, not agents, applications are providing context to LLMs, right? So it's an open standard and it was launched by Anthropic back in November 2024, exactly 1 year back. So before MCP, you had to had M cross N integrations. And after MCP, all you need to do is you need to adhere to the MCP protocol, both the agents and the applications as well as the tools, right? And we'll talk a lot about the terminology which is involved in MCP shortly. So think about it as a simple USB port for AI applications, right? So you have a lot of your applications. It can be Claude, OpenAI, Cursor, IDE. So these are MCP hosts, right? They spin up certain clients, which basically enable connections to MCP servers, which can be remote services, or they can also be your local data sources, things residing on your desktop, in your local databases, or remote services like Gmail, Google Calendar, Slack, and so on, right? So it's a USB port because it's a standardized protocol, right? And that's the effectiveness of MCP. Now, let's have a closer look into exactly what's the benefit. So MCP servers are the more common implementation of MCP, although you can also develop an MCP client, right? And we'll dive more into what these actually mean. But I just want to show you a brief snapshot of what is enabled by an MCP server. So let's say you have a Slack MCP server, which is Slack as a company is launching its own official MCP server, right? And GitHub already has its own official MCP server. So before MCP came in, GitHub definitely did have its own APIs, right? Where application developers wrote code to connect to the API. But now what happens is GitHub exposes the tools as MCP tools, and these tools adhere to the MCP protocol, which is they follow a standardized method of communication. So you can have list pull requests, you can have get repos, and you can have a lot of different functions, basically functions for anything that GitHub that you can do with GitHub. So you can have multiple tools and multiple functions similar to how you used to have with APIs. It's just that it's standardized now. And one of the benefits here is again dynamic discovery, that with MCPs, if you have implemented your application in an MCP friendly manner, and you can do multiple things. For example, you can have an LLM prompt that get open pull requests on my repository and send me a Slack message with the list of pull requests. So it will connect to the relevant tool. It will automatically dynamically discover the proper tool from Slack and from GitHub, and it will perform that action for you. So you can see that it is becoming more and more powerful. And if you expand this to more MCP servers, the connection of your application, right, you can actually do a lot of other things. So it becomes quickly very powerful, and the engineering effort does not scale. It is limited to your MCP development, that you should adhere to the MCP protocol. So this is the main benefit. Now let's look at a few other use cases. If you're not already aware, Sentry is a tool that collects track traces from your applications. PagerDuty is a tool to manage on-call and send alerts. And Slack, as we know, is a messaging tool. And I'm just showing a few sample functions here. So let's say your use case is you want to get all the issues and stack traces from Sentry. And for each of those, you want to create an incident in PagerDuty and then send a Slack message to the team involved. So essentially, you are linking the actions in a sequential manner across three different resources or three different providers, which is Sentry, PagerDuty, and Slack. If all of these MCP servers are available, the LLM will automatically and dynamically discover the relevant MCP server, the available APIs, and then automate the entire process. So it can do this for you. It will get the recent errors. It will create the incident. It will notify on call the alert. It will alert the engineer, and also it will send the message to the channel. So this is one of the examples where you can link multiple different tools into a single flow in an automated manner. Let's look at a simpler example, which is more widespread. A customer, let's say, has an unpaid invoice. And what you want to do is you want the AI agent to follow up, notify the team, and log that activity automatically. So let's say the invoice is on Stripe. So you want to list overdue invoices and you want to get the customer details, right? So these functions will be automatically discovered by your agent application. Then the Gmail MCP server will be targeted, where this particular tool will be discovered dynamically by the agent. It will send the email and it will also log the action on Notion as per the user prompt. That is your requirement. So this is one more case where we have linked multiple different applications and performed an automation. Now,
And then just
hopefully
one
so far
second.
it's clear. Yeah.
Yeah, just wanted
Yes.
to announce for everyone. I think there was an issue earlier in terms of logging in. So if folks want to invite their colleagues, that should be fine. There was an issue due to which things were getting logged out, but it has been resolved now. Thank you, everyone. Yeah, Anand, continue.
Yeah. Thanks, Anurag. Okay. So far we have understood the fundamental intuition behind MCP. Now let's look into how does it actually work, right? Good. We have seen a high level overview of MCP. Now, what is it actually doing? Now, before MCP, remember what we mentioned is within our application, we had to write custom tool integrations, which meant, let's say we are mentioning tools or GitHub. So we had to mention the function name and the schema. And if you had 10 functions, you had to mention those details within your application, right? Within certain prompts, so to speak. And then the orchestration framework that you're dealing with would connect to the relevant API and actually execute the tools. This is what would happen before MCP. But by conforming to MCP, you can easily leverage MCP servers, right? And what essentially we are doing here is we are decoupling this particular part where you will see that these two tools are mentioned, get repos and get pull requests. These are now decoupled into a separate MCP server, and what we are doing is we are just putting that layer of MCP in between where our server, which is just our application, is conforming to MCP, and these tools are also conforming to MCP protocol. And that's how the communication is basically happening. So what is it actually doing? Why is it beneficial? Firstly, a lot of functionalities are exposed by available servers in the market. That is, GitHub, let's say, has released its official MCP server. So you do not have to develop this as a developer. And if there is any API change, if there is any development in the future, all that will be handled by the MCP server itself, right? So there'll be dynamic discovery, there'll be dynamic linking, and so on. That's one. And the second thing is you do not have to write a lot of custom tool integration. So you can scale very easily. And basically, a marketplace has basically come in. Now, let's understand the architecture of MCP a bit. So I mentioned an MCP server earlier, and I also mentioned an MCP client. So what do we really mean by these? So there are three main components in MCP. It's a client server architecture. You have a host, you have clients, and you have servers. And host is typically an AI application that the user is interacting with. It can be a desktop app, it can be an IDE plugin, or it can be something like Cursor or Claude, right? MCP client is a more abstract concept, which is basically meaning that it is something spawned by the host application to handle a one-on-one communication with the MCP server. So if the host wants to connect to an MCP server, it basically launches and spawns an MCP client, which does a one-to-one communication with the MCP server. And an MCP server is nothing but an external program which offers certain capabilities, including tools, data access, and prompts. So basically, there are three main kinds of information types that an MCP server can expose. Uh, Strictly speaking, these are called primitives. You have a tool primitive, which is the most common because it's the most relevant for agents and MCP agents. But you have two other primitives, one of which is the resource primitive, which is very useful for RAG applications, right? For the issue of context management we saw earlier. And you also have a prompt primitive, right? But this is the overall architecture. You have MCP host, right? You can have multiple MCP hosts. To connect to a server, they launch one particular MCP client. Let's say they want to connect to two servers, they will launch two clients, and it will be a one-to-one communication. And that server will call, it is standardizing the tools. So it will definitely need to connect to something else, right? The actual data storage, which can be a local file system, it can be web APIs, and it can be databases. So we'll see the flow shortly. Again, if you have any questions, if you are faltering on any parts of this explanation, feel free to put it in the chat and we'll cover this towards the end in the Q&A. Now, let's go back to our GitHub example. And the question from the user is, what repositories do I have? Now, what we are going to do here is we are going to walk through what is happening behind the scenes and where is actually MCP coming in and what would happen without MCP. So if you ask this question, what repositories do I have? The MCP server will, so this question is getting posed and this will go to the client. And first thing is you need to have a list of tools to send to the LLM, right? So there's a list tools request, which will, this is the communication which will occur first from the MCP client to the MCP server. It will ask the MCP server to list all the tools that are there, and the MCP server will return that. Now notice that this is a dynamic discovery, and earlier what would have happened is we would have actually mentioned that these are the tools available to the LLM directly, right? So there would not have been this dynamic discovery phase if MCP were not there. The next step is that the query is then augmented with the information of what tools are available, what schemas are there in the tools, and what is the basic functionality of the tool. And that is then sent to the LLM, right? So LLM is now having all of this information, and if a tool is needed to be executed, it returns a tool call, which is exactly what's happening next. Now, the step after this without MCP would have been that, okay, a tool call has to get executed, and the orchestrator framework, think about LangChain, for example, would just go ahead and execute it. But in this example, with MCP, what would happen is the MCP client will actually request that tool execution to the MCP server, right? And that MCP server will basically get that executed. In this example, we are looking at GitHub. So it will request that to GitHub and it will get that executed. And it will get a result, which we are calling call tool result. Right? So the tool calling here is again kind of abstracted out within MCP, right? And then the next one is obviously you have the tool result, which you give back to the LLM that, okay, this is what you requested for, this is the tool result, and you show the final answer back to the user. So this is the flow, and you can see that there are two main things which are getting decoupled by MCP. Now, one more thing I want to point out here is how does the communication between MCP client and MCP server occur, right? So there are two things. One is the messages format, and this is JSON RPC 2.0, which is basically followed. But the second important thing is the communication, and that can occur through two protocols. One is a local protocol, standard IO protocol. If you have MCP clients and MCP servers on the same system, right, you can do a standard IO protocol. Or if you're dealing with a remote MCP server, right, think about Slack, GitHub, a lot of these are remote MCP servers. You need the streamable HTTP protocol. And this protocol was released in March this year. Although MCP was released November, but there were a few months post which streamable HTTP was released. And why is this important? Is because a lot of the development now is occurring around streamable HTTP protocol, which brings me to MCP authorization and authentication, right? So let's have a quick look into what is authorization in the context of MCP. Now, we'll also come to why is this important shortly. But what is authentication is simply identification of who the user is, and authorization is, does the user have the necessary permissions to actually perform that action? In this case, getting the data from the MCP server. Now, if authentication is not there, right? Or let's say it's not a strong authentication, attackers can impersonate users and leave no trace. And think about this like a token in a header-based authentication is getting leaked, right? So you have a static credential, which is a token, right? And if that is leaked, you will not have a trace of, how that action took place, like who took that action, because that token was basically leaked, right? So it's very essential to have strong authentication. And if you do not have a authorization scope, that is a user who is authenticated, right? Who's identified, but he does not have a scope of what all activities he can do. Think about a overprivileged chatbot and basically deleting a branch through prompt injection, right? That will cause irreversible damage. So both of these are very important, and these are very distinctive things in auth. But you might even wonder, why is auth needed? The first important thing is a lot of MCP servers contain personal data, not public data. So for personal data, you definitely need a layer of authorization. So that's a very common question that comes up, is why do we even need auth? And auth is one of the more important concepts in MCP, right? But the second thing is also that with remote MCP servers, which are using streamable HTTP protocol, authorization and authentication becomes very important, right? Unlike local MCP servers. And I also want to point out one more thing is we looked at how an MCP client connects to an MCP server, right? But there are two things you can note in this particular flow is that the MCP resource server, that is the server that, let's say, you're developing as a developer, which basically is listing down the tools available, is typically different than the MCP authorization server, right? So there are two distinct things. The flow occurs first with the authorization, and then only the resource is returned to the client, right? So there has to be an authorization step, basically. So that's the one thing, that these are two different servers, and an MCP authorization server is a standard server which is governed by the OAuth protocol, which we will shortly walk through. But the main important thing I want to also show is that this MCP server can actually have a second hop, which is it can try to connect to a non-MCP resource server. And we are only going to cover this first part, right? Not the second part, which is a second hop connection, which is not governed by MCP. All right. Now, with auth, you might think that, okay, I do authenticate with my passwords. I can have API keys to access those MCP servers, and all of that is good. But there will be certain issues that you will face. The first issue is, how do you instantly and granularly revoke the client's access to the MCP resources? So if you have given the client access to API keys and passwords, how do you actually revoke it, right? Second question is, do you really trust the client to securely store the user's password or the long-lived API key, right? Because these clients are getting spawned by hosts, and hosts are AI applications. So do you really trust them to securely store the password or the static credentials? And how do you ensure clients are only accessing specific things that they need, not other things that are out of their scope? And also, did the user explicitly agree to give this client access to their data or not, right? So in short, is the client doing what it should be doing, or is it going outside its scope? And how do you revoke its access, right? So these are issues you will face if you're just using API keys and passwords for auth, which is where OAuth becomes very important. And this was an existing, this has been for a long time, right? But MCP developers decided that, a lot of modern organizations have existing identity providers and authorization servers for OAuth. So MCP also adheres to OAuth 2.1, right? And this is basically the field of delegated authorization, where you have, let's say, let me take an analogy of a hotel check-in, right? You have someone at the reception, which is in our case, the authorization server. You have an access token, right? Which is kind of the room key that you get from that reception front desk person, which can open a door. And that door is basically the door to a room, which is your protected resource, right? Your MCP resource. So that's the analogy that we will work with. And once you come to the hotel, right, you check in, you authenticate with your ID. your primary credentials, let's say. What the front desk person does is they issue a key card, which is similar to what OAuth issues an access token. And that access token can only open doors or resources that it is authorized for, right? It cannot do everything. And the second thing is it is revocable. Once your stay has it's done, that access token expires, right? That key card expires. So similarly here also, you can revoke the access token, which is a very important feature of OAuth. So OAuth is basically enabling delegated authorization without sharing your primary credentials like passwords or API keys. So it's very easy to have limitations, and also you can revoke the access of the MCP client or the host application. So again, a quick walkthrough, how is using OAuth helping? With OAuth, we're using revocable access tokens. There is no credentials sharing. There is limited scope. And there is also an explicit user consent. Now, in enterprise ready MCP, this basically translates to using OAuth 2.1 for authorization, for accessing MCP servers, and for authentication, you have two main methods. You have OIDC and you have SAML, right? So OIDC is built on top of OAuth 2. It uses ID tokens, and SAML is basically, it works with SAML-based XML assertions, right? And this is authentication. Both of these are compatible with OAuth 2.1. Right? So these are completely distinct concepts altogether. And the reason why I'm walking through this is because in an enterprise context, an admin wants to put their application under a single sign-on system, an SSO. And even an AI agent which is using MCP is just another application that enterprises want to integrate into SSOs, which is why this becomes very important. And lastly, let's quickly look into the MCP auth flow. So when a user comes in, they start the login action, right? They are redirected to the authorization server, which basically is this, right? And that OAuth server shows a consent screen to the user. The user then basically gives their consent. They authenticate either using their password or two-factor authentication or any IDP, and they're redirected back to the client with an authorization code, right? So this is where all the front and back happens, where you are logging in, you are redirecting to IDPs and so on. And remember, till this point, the MCP server is not even getting touched, right? So all of this is happening between MCP client and mostly the OAuth server, right? This is all of the authorization part which occurs first. And then what I'm calling the back channel is where the access token needs to be obtained from the OAuth server. So there's a token request, right, with the authorization code that, okay, this particular client is authorized. This is the client ID. This is the client secret, right? And the token is OAuth server responds with the access token, the bearer access token. And finally, finally the MCP request goes from the MCP client to the MCP server, right? In the very, very last step with the bearer access token, and it gets the response back. So as a developer, you're only dealing with these last two steps. If you're a developer of the MCP server, all you need to know is how does your OAuth server, say that you should be validating tokens, and that's all you need to do. How do you validate this bearer access token? A lot of this understanding will become especially useful when I walk through the TrueFoundry MCP Gateway, and we walk through how the authorization is done briefly there. Finally, this is one more terminology which should be very clear: dynamic client registration. It's basically removing the hard coding that used to occur earlier, right? So a client developer had a very lengthy process. They had to register for credentials at the OAuth provider. They had to log in, create a new client application, get a client ID and secret, or enterprise admins could do this for the customers, right? But with dynamic client registration, what happens is the application automatically registers itself, right, with the OAuth server at runtime. And this happens by sending a JSON request, right? So there are certain issues because the client registration request is not getting validated, right? So earlier there used to be a lot of manual steps, but this was very vetted, and there were lesser loopholes. But with DCR, there are certain issues that do crop up, but overall DCR is still effective, right? With the automation that it enables. There are certain issues, and DCR is soon going to be replaced with something called SEP 991 in the next release of MCP, which was recently confirmed last month, right? But for now, all we need to know is dynamic client registration enables softwares to be connected to MCP servers without any pre-registration, and it's pretty powerful. Now, let me just show you some resources that would be a good, handy tool to go to if you want to develop MCP servers. I'll not walk through these. So for fast MCP, there are nice set of tutorials that you can look into. It's very simple to create MCP servers. You have a bunch of decorators like MCP.2, MCP tools, MCP resources, right? And so on. So that's given. And we also have certain resources at TrueFoundry GitHub repos, where the first link here is detailing out certain MCP servers, which we use internally. And the second one is a cookbook where you can see end to end how do you build agents with MCP and actually deploy it on TrueFoundry. So it's a cookbook, right? All right. So now let's switch gears and look into productionizing MCP, right? We have discussed a lot about what is MCP, why is it useful, how does it work, and briefly, how would you develop it with fast MCP, right? So if you have followed so far, the next main question that comes up is how do you actually productionize and get value out of this, right? That's our main challenge. So, what are some of the challenges that enterprise face? And this is a very real problem because agents are getting built everywhere, but MCP servers are not that existent in a lot of enterprises today. So, how do we really democratize MCP access and workflows in enterprises? Let's start with a few challenges, right? The first thing is, other than official MCP servers, a lot of real world use cases require MCP servers to be custom built and self hosted. The question then becomes, where do you host these, right? So, how do you host these MCP servers? How do you deploy them, right? Which basically means you have to create an endpoint, and all of remember MCP servers are about, a lot of these are about personal sensitive data, so you definitely need security and governance, and which is paramount to organizations. So how do you really do this? The second challenge is having a central registry, because if in an organization you have multiple developers and each of them are developing their own MCP servers, how do you really see all of them in one place? How do you enable that view along with, again, a lot of governance around MCP servers with the respect to security? So that's a challenge. Then comes the question of access control. Whatever MCP server is built in the organization should not be accessible by everyone. Let's say you have a very sensitive database within the company. Only certain applications which are in production should be able to access that MCP server, not every developer out there. So you definitely need role-based access control. And again, more granular, the better, right? So we'll walk through how this is enabled by TrueFoundry when we come to that. Then is the question of authentication and authorization. So typically building MCP servers is doable by a lot of developers, but then authentication and authorization becomes a bottleneck. How do you actually enable that, right? So again, that's a bottleneck. The next is agent registry. So democratizing MCP access means that folks can easily build agents, which is basically nothing but prompts, LLMs, and a bunch of tools which are provided by the MCP server. So it's very easy to build agents with MCP, but developers should also be able to register their agents so that others can use it, right? So how do you do this? And guardrails are all about security, because remember, LLMs are not always predictable. They can do things that they should not be doing, right? And according to this, information can also be leaked, right? So if they're given certain tools, they can do whatever they like with them. So you need to have certain guardrails in place that particular LLM application should not be doing certain things. For example, if there is a tool in the company which can delete certain records of users, you can have a guardrail that says, okay, always ask for manual approval before calling this tool, right? So you can build custom guardrails as well. And a simple guardrail example is removing personally identifiable information. Then think about observability, which is having a look into what is actually happening beneath the hood, right? Detailed analytics. Again, if you're doing this at scale, it's becoming very important because what order are the LLMs calling the tools, right? What is happening because of that? That entire flow has to be very clear. And when I'm saying observability, it does not only mean like the metrics, it also means the exact traces that your particular prompt is triggering. And finally, rate limiting and caching becomes important when you are scaling MCPs, right? If you are having a very large scale of operations with generative AI, LLMs can enter loops or end up calling certain tools very, very frequently, and you can easily spin out of your budget as well. So you need to enforce rate limiting, and caching is also important because if let's say you are doing search, you're doing web search, each web search call is a cost to you, right? So if you have already searched for something, you might want to cache it so that you do not need to search for it again, right? And it automatically returns the cached answer. Now, this is where a TrueFoundry MCP Gateway actually comes in. And the fundamental thing with the gateway is that it's a central control plane. So the way it is designed is that it solves all of these challenges, right? Obviously, along with a lot of implementations in place. But the design is one key aspect. Without an MCP gateway, each developer is basically, developing multiple MCP servers, and it's not really visible by other developers, and it's all very fragmented. Now, with an MCP gateway, you have an enterprise-ready platform which is centralizing access to AI development tools using MCP, and you're not managing hundreds of individual tool configurations across development teams. You can basically have security in place, you can have strong governed access in place through a single platform. Now, this is what the TrueFoundry MCP Gateway architecture looks like. So let me quickly walk through what are we enabling here. Think about some key areas where this is useful. The first thing is AI agents do not require separate connections to each MCP server, right? So each AI agent is not connecting to the MCP server directly. They just connect to one gateway and they can access multiple MCP servers, right? This is our classic integration problem, which is very efficiently getting solved by MCP, right? Again, it takes a lot of things to get this working because you have an authorization layer as well, which I will dive into. But if you take a step back, if you look at a high level, this is a very nice area where MCP gateway is coming in. The second thing is the central IT team, right, is managing cloud hosted MCP infrastructure via streamable HTTP instead of developers managing their own MCP servers locally, right? So the central IT does have, a very strong control and view over the security related to MCP, right? Because they can see exactly what's happening. And one more important thing is there is centralized credential management, right? Because again, we are using OAuth. And the way TrueFoundry is enabling the token management is very efficient. The tokens can be mapped to hundreds of MCP servers, right? So one token can be translated to multiple tokens, whatever is required for the MCP servers. And I will again explain this shortly in more detail. So there are a lot of things which are getting enabled. It's a unified MCP server. There is authorization, complete observability, smart selection of tools, and obviously guardrails. And all of this is getting enforced by the MCP gateway. Now, at TrueFoundry, we provide a three-layer auth system, which brings a lot of robustness in. Now, let's understand this aspect a bit. Uh, A user can either authenticate using TrueFoundry token or more commonly an IDP, which supports OAuth 2.0 and above, like Okta, Azure AD, or anything else, right? The gateway then, which is the first step of verification, it verifies the IDP token and it extracts the user details based on the SSO settings, right? Then the access control is checked for, which is basically the TrueFoundry control plane. It handles the OAuth 2 flows and it verifies whether the user has access to that MCP server or tool. So it does the authorization flow, right? Again, with IDPs, this is basis what the infra team or the platform team would have given you access to, right? Do you have access to that MCP server or not? So this access control is basically checked. And then finally, the user's details are mapped by the control plane to tokens that the MCP server needs, right? So remember that the tokens that the MCP server needs is very different from these tokens that we are talking about on the left. These are different, right? So this translation is a token management which is occurring by TrueFoundry and which is a very powerful feature because the translation can be such that one token, right, whatever your token be after the second step, if you are trying to have connections to 10 MCP servers, each of those MCP servers will require a different token, right, in order to work. And this 1 to 10 translation will then occur through the gateway. So that's a very interesting feature with the gateway. Now the tokens can be of two types. They can be static or they can be dynamic, and we'll cover this when we come to the features. Okay, let me skip this. This is a very high level snapshot of the different things we just talked about, a bit more technically. Now let's go through the TrueFoundry MCP gateway demo. And firstly, let's deploy an MCP server, right? So let me just stop sharing and quickly reshare. Okay. So we'll go to this particular GitHub repo, and this is again on TrueFoundry. This is a very simple calculator MCP server, right? And what you can see is the code is in main.py. It's very simple in this case because there's no authorization authentication in place, and it's a very simple server. So we are just importing fast MCP, and you will see that for the different functions, we just have a decorator, mcp.tool, obviously after initializing MCP. And finally, we are just transporting, running this over streamable HTTP protocol, right? So this is our main.py. Now, what does it take to really deploy this? So let me go back to our platform. You are on the deployments tab. I've already deployed this, but I will just show you the steps involved. So we go to new deployment, you go to service, select a workspace, which is, let me pick this one. And we need to deploy the code from the Git repo. Let me just call it simple calculator demo. Again, we do not have a Docker image, right? So let me paste the link of the repo, right? So this will load this. We'll do the Python code based deployment. So this is simple calculator MCP. We want to run Python main.py, right? Because that's a file. And Python dependencies need to be mentioned. So this is going to be installed through pip. So pip install -r requirements.txt. That's basically what will get executed here. And I'll just mention the port to be 8000, right? Remember, this command is going to get executed relative to this particular path. And that's it, right? So let me just submit this. So now the Docker image will be built, and it will basically create a container, and that will be deployed on Kubernetes, right? So that's what's basically happening. And it will take a few seconds to happen. right? There was already a previously built image, so this is happening a bit quickly, right? So let's wait while this occurs. We'll come back to this. All right. So what we'll do is I've already entered the details, and I will also show you how you can use the MCP inspector, right? In the meantime that this is getting deployed, let me walk through a few features. So the first feature is the auth mechanisms. Now at TrueFoundry, with the TrueFoundry MCP Gateway, you can have three main auth mechanisms. You can have no auth, which is good for demo APIs or APIs for public MCP servers like calculator and so on. You can have header authorization, which is ideal for APIs which are using static credentials for access control, like Hugging Face, for example. And you can have OAuth, which is basically very recommended for production applications, which is supported by many of the more popular MCP servers like Slack, GitHub, Atlassian, right? A lot of the remote MCP servers use OAuth. Now, a few cases, use cases which are covered here is that TrueFoundry users uh, accessing OAuth-based MCP servers. That is one use case which is satisfied by the MCP gateway. In this case, TrueFoundry users would be even in your organization. If you're using TrueFoundry already, you are a TrueFoundry user, right? The other use case is the second one, which is end customers accessing OAuth based MCP servers. They can also do that, right? They can also access these MCP servers if their IDPs are configured. And finally, obviously, you can have bearer token based MCP servers as well, which is yeah, which is also possible. All right, so let me go back here and just show you that this is now running. And this is the endpoint of our simple calculator demos. If I open this, it will take a few seconds to come up. Let me copy this. Right, so you'll see that this is the it basically is working. It's up. You can see that this is the JSON RPC 2.0 and so on. But I will show you a more cleaner way to actually inspect it. So you can run that command that had on the slide of the model context MCP inspector. I've launched this already. So the transport type is streamable HTTP. Let me put the URL, which will be this, right? Exactly that endpoint slash MCP. And there's no authentication authorization, so I'll just connect it, right? Let me do one thing. Let me relaunch this. All right. So let's run this again. All right, it's connected. And you can see that if you go to tools and you do list tools, you will see all the tools here, right? And you can actually inspect whether your MCP server functions and tools are working or not. So if I do this, I can just add and I can just run something. It will just run and tell me. Right. So this is just a very basic MCP inspector already available. You can also inspect, but what this verifies is your MCP server is up and running, right? Which was our goal for the example. All right. Let me also quickly show you the authorization part. So if you go to MCP servers here and let me just show an existing server, let's say the GitHub MCP server. I'm just clicking edit. You will see that, you have this auth data, which you can mention, which is header auth, OAuth2 or token pass through, as well as DCR is also there, right? So you have these details as well that you can mention for the authorization and authentication. All right. The next thing is access control, which is also of very high importance. So TrueFoundry MCP Gateway allows access control, right? So you have RBAC, role-based access control at MCP as well. So one interesting thing here is you also can do access control at a tool level, right? Which I will shortly walk through. This is the example that I am walking through, that a finance manager needs access to, let's say, SAP and they need read only on billing invoices. They do not want any payment execution, right? Although this is also enabled as a tool by SAP in its MCP server, you do not want that tool to be enabled. Even by mistake, that LLM should not be doing this. The second service is Jira, and the manager wants to create only tickets for expense approvals. So open new requests, but don't close audits or any issues. And then finally, post updates on Slack, but do not create any channels. Although again, that's a functionality by the Slack MCP server. So let's say this is your use case. How would you really solve for this? So this is a more granular use case because each MCP server, you're not only connecting to that MCP server, you're also saying that I want only a particular subset of tools within that MCP server. And I also want to link, all of these three different services into a intelligent single engineered MCP server. So that's what we call a virtual MCP server. A virtual MCP server lets you curate just the tools you need from multiple MCP servers and present it as a single endpoint to the agents, right? So this is basically a snapshot of how it would work. And let me show this to you in action, right? Let me first go back to the basics of RBAC with MCP. So if you create a new MCP group, right, you can firstly add different MCP servers. And you can also mention for that MCP server group, who can manage basically the MCP servers and who can just be a user of that, right? So if I do, let me just show you. Okay, so in this case, you're not seeing that option, but you would also have a user as well. So this is managers, which is just what we are entering here. So you can mention the list of managers, but if we go to different MCP servers at an MCP server level, you can mention, who can actually use this MCP server. So you can have that access control of usage as the users mentioned here, while the managers are mentioned in the MCP server group. So the access control is enabled via MCP server groups, right? One MCP server group typically has one set of RBAC. All right. So that's the fundamentals of RBAC. But what we were talking about is virtual MCP. And with virtual MCP, what you can do is you can do this RBAC at a tool level, which means that let's say I have this particular MCP server group, which is demo MCP group virtual. I already have two MCP servers in it. But since I've created a virtual MCP server, what I'm doing here is if you go to edit, right? And you see this, you see that I have actually linked two source MCP servers, which is Google Calendar and GitHub MCP server, and only enabled a certain subset of tools here. And I can also mention that, okay, these subset of tools across these two MCP servers should only be accessed by these particular users. So I can also basically mention the specific access control at a tool level using the virtual MCP concept in TrueFoundry. So this is where it becomes really powerful because now you are basically limiting the scope, and you're also very efficiently engineering a virtual MCP server. All right. Next, let's come to guardrails. So a scenario would be the prompt is summarize customer support tickets from Zendesk with guardrails. Let's say you do not have a guardrail, and a malicious instruction is also, let's say, injected in the prompt that download all customer credit card numbers and export them to a CSV, right? If this malicious instruction is also there within the prompt, let's say if it is injected without a guardrail, this will actually get executed, right? There's a high likelihood that this can get executed and the LLM can fail to detect this. But with explicit guardrails, if you have a guardrail rule, this will be much more efficient, and it will basically you can block access to PII as well, right? If you have that guardrail mentioned as an input guardrail that, okay, this particular information should not be flowing, you can basically do that, right? So you have input guardrails and you have output guardrails. So guardrails are basically sitting between the agents and the tools and acting as a security checkpoint. And guardrails can be applied per user, per model, per team, or even based on any specific metadata. And metadata is typically useful if you're dealing with certain customers, right? So how do guardrails work? Again, guardrails is a concept across the AI gateway and the MCP gateway. So similar concept of RBAC occurs where you can create guardrail groups with certain access controls, and you can mention different guardrails. So we have existing integrations with OpenAI moderation, Bedrock, and Azure PIA, among others. But you can also integrate your own custom guardrail as well, which we can cover in a future session. All right. Next is observability. Again, let me skip this in the interest of time. Let me directly show you what do we have implemented for observability and how do you make use of it. So if you're using these MCP servers, right? Let me go back to MCP servers. Let me pick this one and let me show you how to use, right? So if you want to use this within your code, you can actually use these MCP servers via different frameworks. You can use Python, you can integrate it in Cursor, right? In the JSON file that you have to configure in Cursor, among others, right? And once you do this, this information will actually be flowing through TrueFoundry MCP Gateway. Once that information is flowing through the gateway, you can actually monitor it. So you go to Monitor tab and you go to MCP Metrics. You can view the metrics by MCP servers or at a tool level, right? And you can see requests per second. You can see the request latency at P99, P90, and P50, and you can also see request failures. So you can do a lot of analytics, but more granularly, you can also go to request logs and you can filter this, let's say by right? TFI. So I had run some queries earlier. So you can see that you can also see certain details of the traces here. And let me make this last 6 hours, right? So you can also see the specific traces and you can fetch this via API as well, right? What are the traces that you want to fetch? So this actually gives you a lot of insights into the security aspect as well, because if you are seeing a lot of let's say latency is suddenly 20 seconds, latency is suddenly very high. What's happening? Is the API slowing down, or is there a recursive attack loop, right? So observability is also very important for security purposes. Let me also walk through rate limiting. Again, rate limiting is important. If agents are stuck in the loop, you can actually, your cost can spiral out of control and tools will keep getting called without boundaries. And another issue can be quota drain, where let's say you have a random user, who's doing a lot of experimentation and burning through very let's say GPT-4 tokens overnight, leaving no quota for real users, right? So that's again a issue that you can easily fall into without rate limiting. So with rate limiting, you can mention certain rules that, okay, for a specific user, across users, for a specific model or across models, these are the particular rules. And you can actually have nested rules where the order of the rules matters, right? So you can actually create nice complex workflows that actually satisfy your specific constraints. I'll walk through the demo of this towards the end shortly. And lastly, this is the last feature that I'll walk through, is the supply chain security for MCP servers, which basically means that MCP servers can be procured through, let's say, public GitHub repos, right? But those are typically unvetted because you do not know who built the connector, and whatever they are claiming the MCP server to do, is it really built for that, or is it a security leak, right? Where it is basically doing some malicious thing, right? So vetting it is very important. And also one more thing is, let's say you have vetted it once, but you are upgrading it later, the issue can also occur at that time, right? So this is kind of a vulnerability scanning that also occurs for softwares, that is, think about Docker. So this is very similar to that. We already provide certain MCP servers like in the screenshot, which are audited and approved, but you can always add your own remote MCP servers that you have vetted, and that will be part of this particular a group or your MCP registry, where you will see that, okay, all of these are audited and approved. All right. Finally, let me show you the part I skipped around rate limiting. So this is where you can mention rate limiting. You can have certain rules that, you can rate limit to certain requests per minute for a specific subset of requests. Let's say a request is coming for a specific model from a specific team. So you can have a rate limit rule, right? You can also do things like rate limit to 100 requests per minute for every user and every model, right? So you can also do it at a user and a model level, not at a bulk level, but at a very granular level, and so on and so forth, right? So this is effectively a lot of features around MCP. I will now open the forum to a question and answering, and we'll walk through that for any questions.